Everyone, today we'll go through AP Physics 1 2019, question 1, 2, and 3 only because Unit 8, 9, 10 will be removed from AP Physics 1 from 2021. Let's look at number 1. So identical block 1 and 2. So there are two blocks placed on horizontal surface at point A and E. And surface frictionless except for region C and D. So between C and D, we will have a friction there. So I'll just write mu. And beginning at time TA, block 1 is pushed with constant horizontal force from A to B. So block 1, I guess, block 1 will be accelerating in this region. Since it's constant force, the acceleration will be also constant, meaning velocity will increase linearly, right? Upon reaching point B, block 1 loses contact with plunger and continue moving to the right with toward block 2. So there's no acceleration there. So velocity will be constant from B to C. And upon reaching point, okay, we already did that. And block 1 now collide and stick to block 2. So this will be completely inelastic collision. So I guess we'll have to deal with some kind of momentum in this case. After which the two block system continues moving across the surface, eventually passing point F. On the axis below, sketch speed of center of mass. Now this gets interesting because they didn't ask you velocity of the first mass, they actually ask you velocity speed of center of mass until the block pass point F. Okay, so from beginning to the end. All right, so let's think about what is VCM, center of mass, will be basically M1 V1 plus M2 V2 over M1 plus M2. Or you can imagine this as so there's M1 going this way, and let's say there's M2 stationary there, and if they move together as completely inelastic, what is the velocity final? This is actually exactly the same thing, because if you think about conservation of momentum, you have M1 V1. I'll just give you another velocity if I want, plus M2 V2. But if they're moving together, and here momentum will be conserved because there's only internal force between the collision. So you get M1 plus M2 V final. Usually I'm pretty sure you solved many questions like this. And if you want to find velocity final of the two combined mass, then you'll just divide by total mass, right? So V final is M1 V1 plus M2 V2 over M1 plus M2. Now if you compare VCM to this, you'll realize they're actually exactly the same. So VCM, you can imagine as if two blocks combine together, what is the final velocity is actually same as VCM. Okay. All right, but initial part, until you reach point, until you collide, you have to think about how VCM relate to V1. Okay, so let's think about before reaching block 2. If you use this original equation, VCM will be M1, but here there was identical block 1 and 2, so I'll just use M. So MV1, and until you reach there, this is not going to change. So this is stationary, so there will be 0 plus 0 over 2M, because it's M1 plus M2 but they have same mass, so it's just m plus m, which is 2m. So VCM is, until you collide, will be just half V1, okay? So all you have to worry about is this. So this is basically scale down of V1, okay? Now, if you think about how VCM changes before collide and after collide, actually you realize they're actually equal. VCM is not going to change because we know from here, we know from there, M1 V1 before collision, M2 V2 equals after collision, M1 plus M2 whatever VF. So VCM was basically this over M1 plus M2. But since this value equals that value over M1 plus M2, VCM is not going to change because momentum before collision and equals momentum after collision. Basically, the numerator is not going to change. So even if you have to collide this between E and F, VCM is not going to change. So from A to B, you have constant acceleration. So probably I can draw like something like this. And between B and C, remember this is frictionless and there's no acceleration, so velocity or speed will be constant. And then you reach the rough surface, so probably you have the frictional force, which will cause negative acceleration, or it's gonna slow you down. I think you can slow down any way you want. I'll just slow down like this. And between D and E, again, it's not gonna change because there's no acceleration. Now, even if you collide, because momentum before equals momentum after, which is basically the numerator, over total mass is what VCM is, so it's not going to change because numerator is constant. So again, this is equal to m1 v1 prime if this is the final velocity, m2 v2 prime, which is the final velocity of second mass. Doesn't really matter if they stick or not. It's not gonna change. So this will be constant like this. Okay. Now let's move to next question. The plunger is returned to its original position and both blocks are removed. Now you change to uniform solid sphere. Alright, so I guess this will rotate. So if it's rotation, probably you have to think about alpha, you have to think about moment of inertia. It is placed at point A. The sphere is pushed by plunger, same scenario as before. And constant horizontal force is directly towards sphere's center of mass. The sphere loses contact with the plunger at point B and continue moving across the horizontal surface. In each interval, if any, does the sphere's angular momentum about its center of mass will change. This is a little tricky question because, I mean, if you want to get to the point quickly, angular momentum will change when there's torque applied, right, to the ball. But here, the torque could be only applied by actually friction here. So if you get to point C to D, right now it's moving with a certain velocity here. It's moving with a certain velocity there. But once you reach here, once you reach C and D, there'll be friction and this will make it rotate. Now this gets to a tricky question. So I know the answer, which will be C to D, but I'll explain what happens throughout. Okay. So between A and B, I'm assuming the plunger is pushed. Actually, it doesn't really matter where you push. They push there. So there will be force applied. Remember, force equals ma. But this is translational acceleration. Okay, so I'm going to call this mass A, and we use the notation center of mass. Okay, so basically, this mass will accelerate with ACM. So between A and B, it's accelerating this way. Between B and C, it's not going to accelerate, so you have certain speed. But what's important here is, because there's no friction between A and C, there's no torque applied. So basically, this ball is sliding with certain velocity. Okay, it's just moving forward, but it's not rolling. Okay, it's not rolling. Once you reach C, what happened is, if you draw free body diagram, there'll be friction. Okay, so this friction will be kinetic friction actually. So there's a force of friction. I know if you want to calculate, it's mu k, probably mg, because it's mu k normal force, but you don't have to really figure this out. There will be a friction. So if you look at what happened to the velocity of center of mass, that means how fast it's moving. This will actually slow down because you have force there. Remember, this is velocity, not a force. There's force going backward, so your acceleration will be backward. Okay, will be backward. So VCM will slow down. So VCM probably goes like this. Okay, between C and D, or time. If you can say this is distance over time if you want. Now, what this does is actually, until you reach C, this sphere did not rotate. Now there is torque, so this will start to rotate. Okay, and remember, torque applied by this force of friction will be I alpha of this sphere, where you have to use moment of inertia of moment of inertia of the sphere, but I'm not going to get into the detail. But what I'm trying to say is there will be angular acceleration, so this will spin faster and faster. But remember, you're still sliding. Okay, so you're still sliding in that case. Anyway, and then once you reach D, so probably what happened is VCM is decreasing, but there's rolling speed is increasing until you reach D. Then it's gonna roll with same speed. Okay, so that's what really happens. Usually this question comes in physics C. Okay, usually this one will be asked on physics C, but here I think they just give you intro question on this concept. Okay.